Again, it's a rich thing.
What is going on, guys? Welcome back to the Go programming tutorial series. In today's video, we're going to talk about structs, so let us get right into it. Alright, now one thing that you need to know about the Go programming language is that it is not object-oriented. We don't have classes and we don't have objects. What we do have, however, are structs, and structs are basically data structures. You can say they can have attributes, properties, they can have functions, and they can even have constructors. But they're done in a different way, it works in a different way, and we don't have any classes and objects in Go, because Go is a very simple language. It likes to keep things simple, so we don't have object orientation. However, in order to define a struct, let's say we want to have a computer object, for example, or a computer structure would be the proper term. If you want to have a computer structure in Go, what you do is you say type, this is the first keyword, then the name of your struct, so for example, type computer, and then the keyword struct in the end. So type computer struct. And then we open up these curly brackets here, and in between those, we put some attributes. So for example, a computer can have a manufacturer, like that. And this is going to be a string. Manufacturer, come on, like that. This is going to be a string. Then we can also have RAM, for example. And RAM is going to be an integer in gigabytes. We're going to have, for example, a CPU brand, which is going to be a string. And we're going to have a Boolean, which is going to tell us if this computer is a laptop or not. So true or false. And we don't need the commas here, by the way. There you go. So this is a computer, and it has those 4 fields. And now in order to create an instance of that computer object, what I have to do in Go is I have to say something like comp1 is equal to, and then I can say computer, opening up these curly brackets, and then I can say, like in a dictionary, manufacturer is, for example, Lenovo. And then I can say RAM is 16 gigs. CPU brand is AMD. And laptop is true. There you go. So this is now my computer, and I can go ahead and say stuff like fmt.println, and I can print this computer object as a whole. And we're going to see that the values are in there, as you can see here. But I can also go ahead and say, for example, give me comp1.ram. So I'm only interested in the RAM. And if I want to do that, I'm going to just get 16 as a result here. So I can access these fields by using the dot operator. So this is very simple. Now what we can do here, instead of doing it like that, we can also build a constructor. Now this is not mandatory, but we can do it, and it is considered, I don't want to say best practice. Maybe it is best practice, but it's definitely a good practice to have constructors here. And how do you do a constructor? How do we create a constructor? We create a function, which we call, for example, new computer. And this function is going to return a computer pointer. We talked about pointers in the last video. And the parameters here are going to be manufacturer, which is going to be a string, or let's go ahead and just call them M, string, R, int, C, string, and L, bool, just to keep things simple here. This is not best practice, obviously. So what we can do here is we can create a new computer. We're going to call it, or actually C is already used. We're going to call it CMP. And CMP is going to be a computer with a manufacturer, which is going to be M, with a RAM that is going to be R, with a CPU brand that is going to be C, and with a laptop Boolean, which is going to be L. And then we're going to just return and CMP. So we're going to return the pointer to this computer object. So this would be a basic constructor. And we can actually create a second computer here, which is going to be new computer. And here we're going to say Dell. We're going to have 32 gigs of RAM. We're going to have Intel. And this is not going to be a laptop. There you go. And we're going to print that as a whole object. And we're going to see that this also works. So this is how you build a constructor. Now, I think we have to dereference it if we don't want to have the pointer element here. There you go. But this is how you build a basic constructor. Now, what you can also do is we can have a default constructor. Now, there's one problem with that, however. In Go, and they did this consciously, you cannot overload methods. So you cannot say, okay, I have another new computer where I say function new computer and it has a different signature and thus it's okay. This would be possible in Java, for example. It is also not possible in Python, but what we can do in Python at least is we can say something like, okay, we have m and m is a string, but m is optional by setting it to a default value. This is also not possible in Go. If you want to have a default constructor in addition to that constructor in Go, you would have to call it something else. So you would have to call it, for example, new computer default if you want to. And then you don't pass any parameters and you say, okay, it also returns a computer pointer, and you create a computer object here which has a manufacturer empty string, and, or you can say default. It has a default of 4 gigs of RAM and a CPU brand which is also default, and it's not a laptop, for example. This would also be possible, so we can go, and we need, of course, to return it, return and CMP. And we can go ahead and say comp3 is going to be this new computer default. What do we have here? Oh, default, there you go. And then we can go ahead and say fmt println comp3. Now, one thing that you can do, of course, is you can use variadic functions. So with a variable amount of parameters, but that is, you know, then you need to check, okay, does this parameter exist? Does this parameter exist? And so on. But as you can see, this also works. Of course, we can also dereference it, but this is a default constructor. There you go. What we can also do with structs in Go is we can add methods to them, and not methods like these constructors, because those are actually functions. We have new computer. This is just an independent function which returns a computer pointer. What we can do is we can add methods to the actual struct. So we can say that there are functions that we can call like comp3.myFunction, for example, or my method actually. And in order to do that in Go, we need to specify the object or the struct after the function keyword or after the func keyword. And for this, we say, for example, C and then computer pointer. So this is how you do it. You say function C computer pointer and then the name of the function. For example, let's say increase RAM. And then the parameters here, for example, amount, which is going to be an integer. This is how you specify this in Go. By doing that, this C here, this computer pointer, is going to be the element that you call it on. So if I do comp3.increaseRAM, which is now a method of the structure, this means that comp3 is becoming, or C is becoming that comp3 object. So whenever I do something with C inside of that function, I'm actually working with the object that called this method. So what we can do here is we can just go ahead and say c.ram plus equals amount, like that. This is a very simple method, but we can go ahead and actually let's delete some of that stuff here. Let's just work with comp1. We have this computer here, and what we can do is we can print a whole object, and then we can say c or comp1 dot increase RAM by 16 more gigs, and then we're going to say fmt println comp1, and we're going to see that the comp1 object has changed, or the structure instance has changed. As you can see, we now have 32 gigabytes of RAM by just calling this method. Now we can also make another method or define another method which is going to be also called onComputer. And this is going to be print information or print info. It's not going to take any parameters, and we're just going to say, okay, fmt.println, We're going to print computer info, and then we're going to say fmt printf, and we can say manufacturer is going to be a string, and it's going to be c.manufacturer. And we can copy that, and we can do this for RAM. It's going to be RAM. There you go. CPU brand is going to be the CPU brand. And last but not least, we're going to say laptop. And actually, we're going to have a string here because we're going to say, what was it called? String conf, I think. Yeah, string conf format bool, and we're going to format laptop into this here. What's the problem? Oh, c.laptop, obviously. There you go. So this is the print info function. We can go ahead now and say, okay, comp1.printinfo. Then we increase the RAM, and then we say, actually, we don't need the fmt print line. We just need to say comp1.printinfo. Come on, comp1.printinfo. And that's it. So let's see. There you go. Okay, we should probably add some \n's in the end here. So \n here, \n here, \n here, and last but not least, \n here. Then this should work. There you go. You can see we have the print info method and we have the increase RAM method. So this is how you do, how you define methods for structs in Go. So last but not least for today's video, I want to talk about interfaces. And for this, we're going to define an interface up here. We're going to call it shape. So type shape is going to be an interface. And an interface basically just tells us which functions some struct has to implement in order to be of that interface, you could say. So let's say we have the function area for the shape. You can also add stuff like circumference and so on. And this area is going to return float64. So then we're also going to have two structs. We're going to have type circle, which is going to be a struct. And this is going to have, it's going to have a radius, which is going to be float64 as well. And we're going to have a rectangle, which is going to be a struct, and it's going to have a width, which is going to be a float64, and it's going to have height, which is going to be a float64. There you go. So what we can now do is we can define a function, or now we don't have the methods or the method area for these structs, but when we have this function or method, what we can do is we can have one more method, or function, which for example is some function. And this function does not take a rectangle. It doesn't take a circle as a parameter. It takes a shape as a parameter. We can do it like that. So we can say some shape, which is going to be from the interface shape. And this basically tells the function that whatever this object is, it implements the function area, and if we specify more than just one function, it implements all these functions. So it doesn't matter if it's a rectangle, it doesn't matter if it's a circle, a triangle, whatever it is, it implements this particular function or those particular functions specified in the interface. So this function, some function, doesn't need to care about, is this a rectangle, is this a circle? It just calls the functions. So let's implement these functions up here. We're going to say function called on a circle C. Area is going to return float64. And this is going to return circle dot radius times 2 times math.py. And we need to import math, obviously, which is done automatically in Golang. So this is the area of a circle. And then we're also going to say, okay, if it's a rectangle, the area function is going to be different. It's also going to return float64, but it's going to just return r.width times r.height. There you go. And now we can go ahead, for example, this is now a very trivial example, doesn't make any sense to do it like that. But what we can now do is we can go ahead and say fmt println area of the shape. And then we can say fmt.println shape, some shape dot area. So if we pass a rectangle, we're going to get the area of a rectangle. If we pass a circle, we're going to get the area of a circle with a different calculation, because obviously the formulas are not the same. And this goes for all functions that we put in here. So for example, we can also say print name, and we can implement the print name or print description. And if we call it on a circle, it's going to say, hey, I'm a circle. If we call it on a rectangle, it's going to say, hey, I'm a rectangle. This is how this basically works. So let's go down here and create a circle one, which is going to be a circle with a radius of, let's say, 23.45. And we're going to have a rectangle, rect1, which is going to be a rectangle. And it's going to have a width of, let's say, 87.2 and a height of 22.435. And now we're going to just say some function circle1 and some function rect1. Do we have a problem here? Area method has a pointer receiver. What did I do different here? Oh, we need to pass the pointer to the rectangle and the pointer to the circle. So that should now work. As you can see. So this gives us the possibility to be a little bit more dynamic. We have a function that we define for all shapes, and this works, of course, for other interfaces as well. So you can say interface human, and then you have student, teacher, worker, and so on. And you can all pass them as a human object, as a human interface to some function. And then you can call the individual methods for these particular structs. So that's it for today's video. Hope you enjoyed and hope you learned something. If so, let me know by hitting the like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you very much for watching. See you in the next video, and bye.